Shark Shield is a personal electronic device that creates an electromagnetic field to deter shark attacks and is used by surfers, scuba divers, spearfishing, and ocean kayak fishing. The electrical waveform used in the Shark Shield is based on a technology originally invented by the KwaZulu-Natal Sharks Board of South Africa in the 1990s, developing an electrical shark deterrent. The SharkPOD The Shark Shield device was developed by the Australian company SeaChange Technology Pty Ltd, and commercialized by its trading company Shark Shield Pty Ltd, established in October 2006. History. The original waveform used in the shark-repelling technology was devised by three inventors, Graham Charter, Sherman Ripley, Norman Starkey, and released in 1995 by Pod Holdings Limited, a joint venture company partly owned by the Natal Sharks Board and the South African government. In 2001, the KwaZulu-Natal Sharks Board ceased distribution of the SharkPOD. All rights of the intellectual property were licensed to a South Australian-based company, SeaChange Technology Pty Ltd, with the inventor Mike West come down developing various application patents which resulted in a commercial product line under the brand name Shark Shield in April 2002. In 2007, Shark Shield introduced the third generation of products to replace the original FREEDOM4, expanding the range of products offered to include the SCUBA7, which replaced the original DIVEO1, and introducing two new designs. The FREEDOM7, a versatile option that can be used by a broad range of ocean users, including scuba divers, spearfishers, boaters and kayakers, and the SURF7, designed to be fitted onto a surfboard stand-up paddleboard to offer surfers protection from sharks. In 2016, following 2 years of research and product development, Shark Shield announced the Freedom Plus Surfer product specifically designed for surfers. It removed the trailing antenna of the older SURF7, being replaced with a sticker-thin decal antenna on the underside of the surfboard, with the removable power generator located in the kicker of the tail pad. In addition to traditional ocean sports, Shark Shield products are in use with the US and Australian navies, and recently used by production members in the filming of both of The Shallows and Us. Indianapolis Men of Courage long-distance swimmer Diana Nyad, in her record-breaking swim crossing from Cuba to Florida without a cage, was completed with help from Shark Shield. Functionality. All chondrichthyins have highly sensitive electrical receptors called the ampullae of Lorenzini, located in the snouts. These tiny gel-filled sacs sense electric current from prey at very close distances, typically less than 1 meter. They use these short-range senses when feeding or searching for food. They do not use electrical receptors to track animate objects over long distances. Other senses such as audition and olfaction of the primary drivers. Shark Shield devices create an electrical waveform that creates an unpleasant sensation impacting the shark's ampullae of Lorenzini. When the shark comes into proximity of the electrical waveform, it experiences uncontrollable muscular spasms, causing it to flee the area. The field is projected from 2 electrodes, which create an elliptical field that surrounds the user. Both electrodes must be immersed in the water for the field to be created. Research conducted by the South African National Space Agency in 2012 estimated the Shark Shield electrical field to be approximately 4 to 5 meters in diameter. While sharks are attracted to electromagnetic pulses produced by potential prey animals, the electronic field emitted by the Shark Shield does not attract sharks to the device and therefore would not increase the risk of attracting sharks to the vicinity of the user. A shark's sensory organs are acutely sensitive to low-voltage gradients, enabling them to detect very low-frequency electronic fields of between 1 to 8 Hz at short range, after which the other sensors aid the shark in capturing its prey. The range at which an electronic shark deterrent emits a field that is the equivalent of a prey-like stimulus is much further than the short-range detection facilitates. Should a shark approach the device, the strength of the electric field will get stronger the closer it gets, and will soon cause the shark extreme discomfort, forcing it to turn away. Scientific studies modeling this effect show that the output produced at a 3-meter distance is far greater than that produced by prey, and would drop off significantly beyond a 6 meters radius, where it would be beyond the short-range detection ability of a shark. Tests and research. The original SharkPOD was tested for 8 years off Dyer Island with mainly great white sharks, and was the first electronic device that was proven successful in deterring sharks when tested by Ron Taylor and Valerie Taylor in 1997 against great white sharks, tiger sharks, hammerhead sharks, and other shark species in Australia and South Africa with positive results. They made a documentary about it called SharkPOD. In 2003, C.F. Smith, Department of Statistics, University of Pretoria, South Africa, and V. Pedmores, Department of Zoology, University of Durban, Westville, South Africa, researched estimating the probability of a shark attack when using an electric repellent. Research summary. In 2 series of tests of the SharkPOD, data was collected on the time needed to attack the bait, under power-off and power-on conditions. Conclusions were separately drawn after completion of the first experiment, and after completion of the second experiment. In general, the researchers concluded that the probability of an attack in at most 5 minutes was reduced from about 0.70 in power-off mode to about 0.08 in power-on mode, and in a period of at most 10 minutes from 0.90 to 0.16. In 2010, SafeWork South Australia, the government agency responsible for administering occupational health, safety and welfare laws in South Australia, commissioned the South Australian Research and Development Institute to conduct a study into the effectiveness of the Shark Shield FREEDOM7 product. The research team conducted field experiments testing white shark response to both a static bait and a dynamically towed seal decoy at Neptune Islands, South Australia, and Seal Island, South Africa, respectively, documenting the findings in a research report titled, Effects of the Shark Shield Electric Deterrent on the Behavior of White Sharks. Research summary. A total of 116 trials using a static bait were undertaken at the Neptune Islands, South Australia, and 189 tows were conducted using a seal decoy near Seal Island, South Africa. The proportion of baits taken during static bait trials was not affected by the deterrent. The deterrent increased the time it took to take a static bait, and the number of interactions per approach. The effect of the Shark Shield TM was not uniform across all sharks. The number of interactions within 2 meters of the deterrent decreased when it was activated. No breaches and only 2 surface interactions were observed during the dynamic seal decoy tows when the deterrent was activated, compared to 16 breaches and 27 surface interactions when the deterrent was not activated. Although the fine-scale positioning and presence-absence data collected to assess the potential of the device to attract white sharks was limited to 1 trip, our results did not suggest that sharks were attracted to the deterrent. The results showed that the deterrent deterrent had an effect on the behavior of white sharks but did not deter or repel them in all situations. In July 2016, shark researchers from the Neuroecology Group at the University of Western Australia had published a research into the effectiveness of the Shark Shield shark deterrent on PLOS1. How close is too close? The effect of a non-lethal electric shark deterrent on white shark behavior. The research team was funded by the Western Australian Government and included UWA Oceans Institute Director Professor Sean Collin, Associate Professor Nathan Hart and Dr. Ryan Kempster. Using a modified stereo camera system, the research quantified behavioral interactions between white sharks and a baited target in the presence of a commercially available, personal electric shark deterrent. The stereo camera system enabled an assessment of the behavioral responses of sea carriers when encountering a non-lethal electric field many times stronger than what they would naturally experience. Upon the first observed encounter, all sea carriers were repelled at a mean proximity of 131 centimeters, which corresponded to a mean voltage gradient of 9.7 volts per meter. With each subsequent encounter, the proximity decreased by an average of 11.6 centimeters, which corresponded to an increase in tolerance to the electric field by an average of 2.6 volts per meter per encounter. Despite the increase in tolerance, sharks continued to be deterred from interacting for the duration of each trial in the presence of an active shark shield. Furthermore, the findings provide no support to the theory that electric deterrents attract sharks. The results of this study provide quantitative evidence of the effectiveness of a non-lethal electric shark deterrent, its influence on the behavior of sea carriers, and an accurate method for testing other shark deterrent technologies. The most recent study published in July 2016, the Shark Shield and other shark deterrents were tested by the University of Western Australia researchers. The results showed nearly 90% effectiveness both within controlled environments and the wild. In 2016, in a study conducted by Choice magazine published by an Australian consumer advocacy group, found that only Shark Shield was effective to repel sharks out several products it surveyed.